All right, so welcome everybody. This is a presentation from the Arduino School of Engineering. And today we're going to do some activities from engineering that you can do at home. So today what I want to talk about is a little bit about our design spine sequence at UIndy, talking a little bit about the programs that we have, and then we're going to launch into the activities that we have today. Specifically, they're covering industrial engineering, electrical, computer engineering, and mechanical engineering. So one of the things that we're really proud of in the RBS School of Engineering is what we call the design spine curriculum. And how this differs from a lot of other schools is every single year you are in UIndy Engineering, you are with a team working on projects. And those could be projects from industry, like you can see the pictures here, or those could be projects in-house. So this really gives the students some real hands-on training, working as a team and interfacing with some external stakeholders. 2 years ago, Citizens Energy approached us for a water wagon, so they can bring this to events and give out water bottles and fill water bottles. So this is a really successful project. A lot of these students have now graduated and now they're working for Citizens Energy, but it was a really good experience for all of them. All right, so the programs that we have in UIndy Engineering, we now have 7 programs: electrical engineering, computer science, general engineering, industrial and systems engineering, mechanical engineering, and then finally software engineering. And today we're going to hear from 3 areas. The first is from industrial engineering. Dr. Megan Hammond's going to be talking about ergonomics. And then I'm going to have a little Tinkercad activity, which is really electrical, computer engineering, computer science, software engineering, that sort of thing. And then we're going to end the talk up with Dr. Rashidul Sarkar with a bridge building activity from mechanical engineering. All right, so let's start it off. Megan?
All right, thanks, Paul. So industrial engineering, if you haven't heard of this, it's a really cool field of engineers where basically we get to figure out how to do things better. And those things take on a wide variety of implementations. So we figure out problems like how to shorten the lines for roller coasters, how to streamline operating rooms to make sure that they're fast and efficient, or even reduce shipping time. So waiting for the Amazon box to arrive is some of the problems that industrial engineers try and solve so that we can save time and be more efficient. And what's great about it is the need for an industrial engineer comes from a really large variety, which means we get to work at some pretty cool places like Disney, NASA, Hershey's, and even at UIndy. So our big thing is to make sure we're helping people and do the best we can with whatever problems we're trying to solve. So today we're going to get to figure out one aspect of industrial engineering called ergonomics. And ergonomics is really kind of shifting our focus to people and how we can help them personally with how we design products and how we design spaces that they work in. So some of the things that you might think about that you use every day, but you don't think about how they've been designed, are your desk chair. So that chair has been designed specifically for people to use and thought about how it can be safe and healthy for them to use for long periods or short periods of time. The middle photo you see there is actually from NASA's space program and how they designed the gloves so that they could interface with all of their instruments while they're out in space. So industrial engineers and ergonomics were studied to make sure that that could be done efficiently out in space. And then even in our healthcare systems with the last picture, creating these interfaces to make sure that nurses, doctors, and patients can utilize these really specialized equipment to the best of their ability. So making sure that things run better. That's what industrial engineers do. So today we have a couple of quick activities to kind of think about how we can make things better and understand the human body, because that's the big focus of ergonomics as an industrial engineer. And we take a ton of measurements, right? Figuring out how to design a chair, we need to know how tall you are, how broad are your shoulders, how long can you stretch out your hands, and a lot of important factors. So a couple of really quick and easy ergonomic studies that you can do at home is to test your hand dominance and your eye dominance. So if you have a pen and a paper handy with you, what I challenge you to do is try and write your name once with your right hand and then another time with your left hand. So I can show you what I mean by this. So I did this just a few minutes ago and I wrote my name with my right hand. I am right hand dominant, so it's pretty legible. That's a nice name, Megan. Then I tried to write it with my left hand not quite the same accuracy with my ability to write my own name. So my hand dominance is really measured from that clarity of how well I can write my name. Now, another interesting dominance is eye dominance. And if you haven't heard of that, it basically means how your brain associates how you take in information. So today, when we're on our computers, or if we're at the office, or in our classrooms, eye dominance can be really important to see where we're really focusing when you're looking at a whiteboard or at a screen. So if you're mostly right eye dominance, your vision's gonna focus more towards the right, versus left eye dominance is focusing more towards the left. So a really quick and easy way to measure your eye dominance is through a nice test, and all you need are your 2 sets of hands. So what you're gonna do is go ahead and make a triangle with your hands, and you wanna find an object across the room from you, so a good 5 or 10 feet away from you. What I like to look at is a nice dot. So usually if I have a friend around, I'll have them hold this up for me. Or if you are at your computer right now and just want to get up and take a few steps back, I can hold it up for the camera for you. And what we're going to do with that triangle is go ahead and frame that dot, keeping both eyes open. So you're basically going to be looking through that triangle to make that nice frame. And then one eye at a time. If you shut your right eye and all of a sudden that dot disappears, that means you are right eye dominant. So most of your vision is focusing on towards the right of your face. And then if you shut your left eye, you should be able to still see the dot reappear, which is kind of a fun way to figure out where you're focusing when you're looking at a board, at a screen, or utilizing different objects. So those are just a couple of measurements that we do and take to make sure that we can design things so people can use them better.
All right, thank you, Megan. All right, so the next activity we'll be doing is going to be a electrical engineering activity. And actually, let me show my correct screen. All right, there we go. So my name's Dr. Paul Talega, and I'm going to be doing activity today with Tinkercad.com. Now, the activity we're going to do today is really related to electrical engineering, computer engineering, computer science, and software engineering as well. And really what we're doing is giving you a little bit of a taste of what you are able to do completely for free with circuits, with possibly some Arduinos, without having to buy anything whatsoever. So embedded devices are really all around us. So this could be a fridge, it really could be a microwave, it could be a computer, it could be a watch. So programming devices is a really good, very good activity to do because there's actually a lot of jobs for that in the market. So let's get started with a Tinkercad activity. If you go to Tinkercad.com, you should be able to create an account for free. And let me switch over and, sorry, show you what the dashboard looks like. Okay, now once you log into Tinkercad, there's a few different areas that you can look into. The 3D designs over here on the left-hand side, circuits, code blocks, and then lessons. So one thing that might be good to do if you're starting this is actually to go take a look at the lessons, and this will walk you through creating a circuit and sort of simulating that, all right? Now what I'm gonna do is actually just jump directly into circuits, and you can see that I've already created a few right here. But the fun thing to do is just click on create a new circuit, and what it's gonna do is open up sort of a blank workspace. Now, some navigation items here. This is your workspace in the middle. On the right-hand side, we have all the pieces of electronics that you can add to this workspace. And also you can change the components. So right now it's showing basic. If you want to see all the components, you can click on that as well. But lower down, you can see there's basic starters, Arduino circuit assemblies, then all of them. And one thing that's nice is just to click on basic, all right? And now I'm just going to click this and drag it over to my workspace. And what this is a battery, a resistor, okay? And then a LED. We call this a LED, or a light emitting diode. It's sort of like a light bulb, okay? So this is the same as if you were to go out and actually buy this electronics kit and sort of put this together yourself. But the awesome part about this is there's a start simulation button up here. And if you click on that, the light bulb comes up, okay? So it starts this and it actually runs, okay? All right, and each of these pieces you can change, right? So I'm going to stop the simulation right now, and if I click on this resistor, we're going to be able to change the resistance of that resistor. So right now this is 220 ohms, okay? And let me just put in like 1,000 ohms, okay? So all of you, what do you think? What's going to happen now if I try to run this circuit with 1,000 ohm resistor rather than a 200 ohm resistor? Wrong answers only. Anybody? All right, let's try it. Start simulation. It's not as bright. All right, and that's a good representation, right? So if, let me change this again. Rather than 1,000 ohms, let me put in 1 ohm. And let's run this again. Really bright, and notice there's a little exclamation point here. Current through the LED is blah blah blah. The usable lifetime of the LED might be reduced. So this is showing you that, hey, if you built this in real life, that LED might not work so well after, you might burn that out. All right, let's just go extreme here, and let's put like 0.01 ohm. All right, and now when I do that, I probably get the exact same error message. Yep. Let's stop that, and let's take out the resistor entirely. So if I just click on one of these items, hit delete, it's gone. All right, and now I can click on one side of that LED. And by the way, the long side, if you notice that LED has a long side and a short side. The long side is going to go to the plus side of the battery. Okay, and now if I start the simulation, I get the same thing, right? So this is nice because even without any parts, I can experiment with circuits. All right, so this is the circuit, and let me stop the simulation. If I just want to get rid of this, I can just click this and start pressing delete. Delete all these pieces. We also have motors in here. All right, so here we have a 9-volt battery connected to a photoresistor going to a motor. All right, so let's see what happens now when I start this simulation. And you can see the motor's turning at 6 RPM. Now, just like in real life, right, I should be able to put my finger over this photoresistor. So the resistance of this changes based on light. And if I click on that, now I can sort of move the slider, and you can see the motor changes speed. All right, so when it's very, very bright light, very low resistance, the motor's going to go very, very quickly, just like in real life. Okay, so there's a lot of, these are the basic circuits, and of course you can use any of the pieces that you want by yourself. Also, just to show you, there's also Arduino basics in here. Let me just pull one of these in. Of course, I have 9-volt battery in there. Let's get rid of that motor and all those pieces. And this will actually, if I click on code now, allow me to see this in blocks, okay? Or I can see this in we call C code, which is actually running on this microprocessor. And just like the circuit, it's able to simulate this as well. So if I start the simulation, you'll notice that it's going to be running this, and I don't have time to really talk about this, what this is doing right now. But the brightness of that LED is going up and down. Okay, I can stop this. I can change the code. Right, let's just change that delay to be maybe 1 millisecond. Change this one to be 1 millisecond, and now let's see what happens. You can see it's flashing a little bit faster now. Okay, so this is sort of awesome because we're able to simulate a circuit, simulate an Arduino, and we can learn about circuits sort of through an experimentation process. All right. Okay. All right. So that is sort of the end of my demonstration with Tinkercad. I certainly suggest playing with this. We actually use this in the RBNS School of Engineering quite a bit, just because you're not going to break any light bulbs. You can throw a circuit together pretty easily, and you can also share this circuit with other people, and they can play with it. Okay. All right, next, Rashidul.
Hi everyone. So today we're going to see about that what mechanical engineering do. So in a word, if we say that what is mechanical engineering, it's a branch of engineering where we mostly deal with design construction of machines and machineries. And you can see that one of the side is construction of structure, and the truss is one of the major types of engineering structures in the design of bridges and buildings. And you can see on the left side, this is one part of truss. So what does the truss means? So the truss is nothing but if you have different types of member, one single line of member, as you can see that this is one beam, and all of the beam needs to be joined at a point. If they don't if they doesn't join at a point, it's not a truss. It has to be joined at the point. And whenever the load is applied to the truss, all the point is taking all the loads and all the force going through the member. So there is no bending or shear stress or shear force going through the members. It's all about that force going through along the line. So that's how it makes it more efficient to design a structure that can withstand much more load. So this is the typical type of truss you have seen in your everyday life, some sort of bridge on the bottom you can see. So today we're going to do some sort of activities that what you can try at home and see that how you can improve the design of a truss that can take much more load. So if we go to the next slide, so you can see that we're going to use some sort of, the spaghetti that you have at home. So what you can do, you can take a larger spaghetti and I don't know if you can see it over here, and you can break it in an even distance like that. So right now I have 3 of member. If I call one of the broken spaghetti piece is a member, so now I have 1 member. So to make a truss, it has to be joined at a point. All the members should be joined at a point, and then it's going to make a truss. So what you can do at home, if you have a tape, you can break it multiple member and then put it on top of a tape one by one. On that image, you can see that blue tape is actually upside down. So it has the sticky part facing towards you. So you can place it on top of it one by one like that. And then after, on the next slide, you can see you can put another tape on top of it so that you can make it much more firmer. So this is one truss. So you have to make 2 types, the same type of truss twice, and then you can join together. Then you can make a bridge. So one question to you, that between the truss on this one, the 3rd image and the 4th image, what do you think, which one is going to take much more load? 10 seconds to think about it. All right, so I have that 2 different truss that I made over here, you can see. So this one, I have only a couple of triangle over here, as you can see that 1, 2, 3, 4, 5 triangle. And if I apply load, it is going to withstand some type of load, but at some point it's going to fail. You can see that it's going to fail right now. But if I can put 1 more member in the middle of each and every triangle, it will be made much more stronger. So if I have the same thing with the same dimensions, but I have 1 more member in between the triangle, right? So now I'm just making it much more stronger compared to the previous one. Now it's going to withstand much more load compared to previous one. But you might think, okay, let's make it much stronger. Let's put another member in between, right? You can put as many member in between all the triangle, but think about it, you might do the over engineering. So at the same time, when you make a bridge, you don't want to make it much more expensive. As long as your function is okay, as long as the bridge is working in the manner that what you want to do, that's fine. You don't want to do any over engineering and make it much more expensive. Okay. So this is one type of truss that you can make at home, and at the same time you can make with the marshmallow. So as you can see, I made it over here. So the smaller version on that bottom image left side, you can see 2 truss connected together with 4 other member over here. So you can make it. And I also made another one which has another member in between 1 triangle. So what you can try, if you can make like these 2 bridge and put on top of 2 edge and give some sort of load like a mouse pad or whatever, if we have that can go inside this one, and see that which one breaks fast. So probably you're gonna see this one is going to withstand much more load compared to this one. Okay, so this is one fun activity you can do at home.
Awesome. All right, so thank you, Dr. Rashidul Sarkar. At this point, we're open to any questions that any of you might have. No. All right. So I just want to thank you all for coming to our talk today about this RBN School of Engineering. Hopefully you got some ideas on activities that you can do at home, finding your dominance, playing around with code and circuits a little bit without making the magic smoke disappear. And then lastly, building some bridges out of pasta. Okay. All right. So thank you all and enjoy your day. Right.
Thank
Bye.
you.
Thank you, guys. That was awesome.
It's a lot easier if you're doing it in real life.
There you go. There you go.